Imagine that you have a security guard standing in front of a building. A security guard that plays in the everyday world the same role that a firewall plays on the network. Someone shows up in front of the building, is trying to get into the building. The security guard has a list of policies that guide them when searching for this person. They search the pockets and all whatnot in search for particular objects. If those objects are found on an individual, the security guard tells the person, you are not allowed to get into the building. Again, if this person were coming from the building and they are leaving the building with computers and some valuable information, the security guard may also be able to stop them from leaving the building and oblige them to return this. This happens in the real world. In the world of technology, firewalls operate in about the same way. When traffic from outside the network is about to get into the network, it gets to the boundary between the outside world and the internal network. The firewall checks this traffic and verifies if this traffic is compliant with the firewall inspects the traffic coming from outside the internal network to see if it matches the policies set aside by the internal network. If it matches, it allows this traffic, into the local network, and then you can work with this. Else, it refuses this traffic. Firewalls use what we call deny and accept rules. The deny rule is the rule that enforces blocking unnecessary packets, while the allow is the rule that lets packets or traffic that is good for the network to go through. Network firewalls are made from hardware and they are usually positioned between networks at the perimeter. And so they are regarded to be perimeter defense mechanisms, for example, between the internal network and the internet. They only affect traffic that has to go through the firewall device itself. Host-based firewalls, on the other hand, they are made of software, or they are actually software that are installed on the individual computers inside the network, and then they control incoming and outgoing connections to and from the computer on which the host-based network is installed. So it is common practice to have a network firewall and a host-based firewall. This is what we refer to as defense in-depth strategy. The mindset here is if the network firewall missed shutting down unwanted traffic, the host-based firewall should be able to shut it down. On Windows, we can actually configure firewalls using the Windows Defender firewall with advanced security. In terms of Windows, you have three types of context: the domain, the private, and the public. Let's review what it entails to configure an inbound rule. An inbound rule is simply a firewall rule that goes into action for traffic going from outside the network into the network, or for traffic going from the network into a particular host or computer. Here, some key verbs are important. There's the protocol that would specify the kind of protocol of interest. There is the port, which is going to specify the port number for the kind of protocol. If it is HTTP, for example, the port number will be 80. There is the action that tells the host based firewall what the action to take. The action will be one of two. It will either be to allow this traffic to get through or to block the traffic or deny it from getting through. You can make this to be applicable to all profiles. And then the green mark in the middle, therefore inbound rule, tells you that this rule is currently active. In today's world with cloud computing, it is possible to virtualize most of the transactions that happen on a, a network that happens on the premise. When we virtualize this, then we have the cloud instance of this. While on the on-premises network, we use the firewall. In cloud, for instance, you might find yourself using some other terminology for it. It's common practice to use security groups for AWS security. So basically, security groups are virtual firewalls in AWS. Whatever you're able to achieve with a real firewall, you could be able to achieve the same with a security group in the cloud. A traditional network will block malicious headers using packet filtering. It will block network connections that are missing using stateful inspection. It will also block a packet that has a protocol packet that has not been properly formed using session filtering. That's all that a traditional firewall can do. The next generation firewall takes this responsibility a step further. The next generation firewall will go ahead to block unknown non-malicious URLs. It will block virus data. It will block unauthorized applications. These three responsibilities cannot be handled by traditional networks. That's why you would need next generational firewalls more. The intrusion detection system, IDS, operates on the following simple principle. If you see something, say something. The intrusion prevention system, IPS, on the other hand, functions on the principle if you see something, take action, stop it. If you visit a museum, for instance, you might have a security camera, and the security camera is able to detect, maybe with recent new technology, is able to detect the moment someone is trying to take snapshots and selfie inside the museum. Normally, this should not be allowed. But if you try doing this, the security camera may be able to pick this up and then it would raise an alarm. Okay, but the security camera will not stop you from taking the selfie. That's an intrusion detection system, how it works. It detects and alerts of any activity that's suspicious, and then you have to take the responsibility, of stopping this. The intrusion prevention system, on the other hand, is like the security guard. If the security guard finds you lurking around the campus of an institution and suspects that you might have evil intentions, the security guard will take an action. The security guard will come towards you, interview you, and then ask you to leave. If you refuse to leave, the security guard can call for backup, and then security, police, or the military would come and arrest you and take you away. That's what IPS does. IPS will detect an activity in real time that looks suspicious, and it would go ahead and block this activity. Most of the tools that we've discussed this far that are involved in security generate documentation about the activity on the network. This activity that they generate is written to files that we'll call them logs or log files. The security information and event management system, SEM, is a tool that is regarded as a central repository on a network that is able to pull entries from all the various monitoring devices in the network. So it pulls logs from this and then puts them together in one location so that you can query these logs and make meaningful information from them. When you analyze logs, you might be interested in logs for connections that have been denied, okay, to see how many people were trying to log in unsuccessfully. That might inform you about the prevalence of brute force attacks, for example. Logs also might inform you about certain funny behaviors, like there is an application that you installed and the application is not doing what it should be doing. It is rather trying to copy files from one location and to send them to a particular IP address. That information is logged too. So if you look at this information, you might sense that data exfiltration is happening. And then you can take actions to block that particular IP address so that traffic is not sent from your network to that IP address. That's one of the things that you can make for. Also, looking at the rich content of log files, you may be able to rebuild or reconstruct an activity and figure out exactly what went wrong before your network was hit. Imagine that you have a library and this library has a librarian, and there is a particular section in the library where you are not allowed to take books out. The librarian's responsibility here will be to do the following. It will be to check using whatever software is available to see that no book was borrowed from this particular section. The responsibility of the librarian as well will be to also check those books and see if there are any pages that are missing. If the librarian discovers that pages of a certain book were destroyed, maybe on a particular day, they will be able to look at the list of whoever visited the library and try to attribute this action to them. File integrity monitoring plays this kind of role. But the difference here is that file integrity monitoring is the last line of defense, whereby the file integrity monitoring tracks change logs, okay, to see what has changed since the last time. If you try to check change logs, you'll be able to figure out what changes have occurred in the file, and then you would see if these changes that occurred on the file are changes that should have happened or they are changes that should not have happened. If there are changes that should have happened, that's okay. But if a file experience changes that were not anticipated, this is a problem. The file integrity monitoring solution will raise an alarm that something is unusual is happening and an action has to be taken against this. The working of file integrity monitoring is based on cryptography. It uses cryptographic hash functions to detect changes that have happened to files since the last time. First, the hash of files are generated and stored. And then periodically, those same files, their hashes are recalculated and then compared with the stored values. If the stored values and the computed values agree or they are the same, then no changes have taken place. But if the stored value does not agree with the recomputed hash, then changes have taken place. The next step will be to ensure that the changes that took place were acceptable changes. If this were a file, a system file, for instance, and the expected norm is that system file should not be written to, if you get the hash value, the recalculated value different, it means that an application has written to a system file. This means that malicious activity must have happened. Malicious actors also know that companies try to use uh, file integrity monitoring solutions. For some companies, the file integrity monitoring solutions just keeps track of the size of the log files. Okay, so malicious actors know about this. So what a malicious actor will do in such a situation to trick your system will be to try to clean up after their activity by doing what? By going to the log files and then trying to delete the log files. And if they do that, you would see that the sizes of the log files are not growing the way they should grow, or they are kind of somewhat normal. They have basically cleaned up their mess to try to, reduce any traces of information that can be tracked back to them. So that's also something that, as a security person, you'll be interested in looking at. If there are log files that have not grown in the last week, meanwhile, in the past few weeks, they have been growing at a particular rate, then that's a cause for alarm. You might want to investigate a little further to see what went wrong. Trade secrets, business plans, health records, and personally identifiable information are sensitive information that are particularly appealing to malicious actors. Malicious actors might be interested in your organization to try to copy this information and to leak them. If they succeed to copy this information and leak them out to the public, this might attract fines and sanctions from organizations responsible for catering for the cybersecurity sanity of an institution. So if an organization is reported to have, you know, sold out or published on the internet passwords or health records or addresses of people, this organization could be fined. And if an organization is fined, the reputation of an organization is damaged. No other organization will want to do business with you because you you were involved in data breach. So data loss prevention solutions, DLP, try to enforce information handling policies so that data leaks and theft can be prevented. They will scan for sensitive data on your systems, monitor network traffic, and try to detect any unauthorized transmissions like any attempts to exfiltrate sensitive data, and then they will alert administrators before any damage occurs. In terms of methodology used by data loss prevention, they can do pattern matching, where they try to match non-patterns against patterns that they find in traffic that's leaving the domain, the company domain. The pattern for telephone numbers, for instance, is known. So if you filter traffic that's leaving the domain and you see a series of 9-digit numbers, you might be able to figure out that someone is copying telephone numbers from the company and sending them outwards. Credit cards also have well-defined patterns, so as social security numbers. And so if any of these patterns are picked up, the data loss prevention solution will flag this as either top secret information that's going out or confidential data is going out. On the cloud, data loss prevention is operated as a service managed by third-party providers to reduce internal resource demands. The security of encryption-empowered systems comes down to the security of the keys used for the encryption themselves. If the keys are lost, then the information that was encrypted using these keys is permanently lost as well. If the keys are compromised, then whoever has the keys will be able to decrypt all bits of information that have been encrypted with these keys. And this leaves the company in a position of vulnerability. A solution to this will be to operate a key management system, KMS. The key management system allows you to create keys, to store them securely, and to rotate the keys if necessary, and dispose the keys off securely. That's the entire life cycle of a key. You create the key, you store it. When it is used, when it needs to be used, you retrieve it from the storage and use it, and you put it back. From time to time, you take the key and then you rotate parts of the key to generate new keys so that they are resistant to brute force. And then you can keep using this. And when a certain key has been used for a period accepted by the company, you can get rid of this key completely and replace it with a different key. When you dispose of the key, that's termination of the key. Hardware security modules are special software that are used for encryption and decryption. They securely store encryption keys and offer high performance and physically are tamper resistant. The trusted platform module is a chip that is built into many PCs and laptops, and it is used for full disk encryption key protection. It prevents encrypted drive access if the drive is moved from one system to another. For rootkits, the BIOS system may be corrupted, and since the BIOS normally runs before the operating system loads, the malicious code will run in this instance, and then it can infect the entire system. With modern operating system, BIOS is being replaced with UEFI, Unified Extensible Firmware Interface. This offers more flexibility and advanced security features. The secure boot ensures that only authentic operating system loaders are executed. It verifies the integrity using digital signatures and vendor public keys. If the verification fails, the boot is halted with an error. If the verification passes, then the operating system is loaded. Web content filtering acts as a gatekeeper by filtering content based on rules that have been predefined. Agent-based filtering is a type of web content filtering whereby an application is installed on an individual device as a computer or a mobile device and filters the content regardless of the location of the computer. With centralized proxy filtering, there is a centralized server that has policies enforced centrally to manage web filtering. So each time traffic comes, traffic gets into the network, the traffic goes first to the centralized server, and then the server validates this traffic, and then it can send it back to whichever device this traffic was meant for on the network. With URL scanning, there is a database of known malicious websites that is established. So every URL that is requested is checked against this database. If this database is found in this website, then such a URL is blocked to prevent or restrict harmful content from getting to a certain device. Site categorization in, uses grouping of websites by certain topics such as news, adult content, and social media to block or allow content based on these categories whenever a website or content is requested within the network. Reputation-based filtering takes filtering a step further. It does not only filter the content, but after filtering the content, it assesses the trustworthiness of the content. It looks at the history of content from a particular website, and it looks at user feedback based on a certain website. That way, every website has a kind of profile or portfolio that has been formed about it. And based on the reputation, you can validate the content as okay, but the reputation knocks this content down, in which case you get to block everything, be it content or otherwise, coming from a certain website because this website is known to have had bad reputation. Information technology is constantly evolving in itself. And if you want to keep with the advances of information technology, then you have to daily make updates to your system. Although this change is important, you need to track these changes to make sure that you have full control of things. Else, you might find yourself behind or you might end up with disruptions. Change management is important because every business wants to always be meeting its business goals. And you don't want to do this at the expense of other operations within the company. You want to keep at barest minimum any risk or disruptions that might occur because of IT changes. It is common practice for a company to come up with a request for change, RFC. When Cisco went from proprietary EIGRP to somewhat open EIGRP, they issued a request for change. A request for change is just a standard document that proposes changes and includes bits of information about the description of the change, what is actually changing, and the impact that such a change will bring about. It's important to have a request for change because it helps with assessing risk. It helps with developing a rollback plan, and it helps to track items that will be affected so that you can take note of their configuration. When it comes to approving workflow that's related to changes within work, there is a chain of command that has to be followed. For minor changes, the direct manager is responsible for approving these changes. For major changes, you would have a change advisory board to sit over this, deliberate, and then move that these changes should happen. The CAB would ensure that there is proper oversight and that risks have been factored into the equation. There are also changes that would happen every now and then. These are referred to as routine changes. For such changes, to avoid having the direct manager approve every time or get the CAB to approve every time, what happens in practice is that a request for change is submitted about these changes, but the changes are effected automatically. In this way, you speed up routine operations without sacrificing control. Software releases are assigned a version number following this pattern: major.minor.patch. For example, iOS 14.1.2 says that the major change that happened is going from iOS maybe 13 to iOS 14. The minor change that happened is gone from 0 to 1, and this is the second patch. Versioning helps to track updates and changes, and in that way, you have consistency across all working environments. Let's discuss the hardware lifecycle, and for this, we will use the example of a laptop. There's a new employee that's just been hired by a company, and the company needs a laptop because this company does not support the bring your own device policy. They actually provide a laptop for their workers. So the IT department would request that there should be a new laptop bought. An order is placed and an inventory record is created within the tracking system. Once the laptop gets delivered, this laptop is matched to the inventory, and then the laptop gets assigned a serial number. After it's assigned a serial number, the laptop is configured for this for the said colleague that's joining, configured such that they have just the minimum necessary privileges to do their task. And then the colleague is allowed to use this over a period of time. When this colleague is leaving the company, this laptop may be taken from them and reassigned to someone else to be used. If this laptop develops faults, it can be decommissioned and then put on the shelf. When you delete data, the data can be recovered even after the file has been deleted. But when you erase data, the data is not recoverable after this process. So what happens during data deletion is that the metadata about this file is removed. The actual content of the file is still on the disk. We can use forensic tools to be able to recover this data. In practice, the content of a file is stored in different blocks, and the blocks are not necessarily sitting next to each other in memory. So metadata about a file tells the operating system where each of these blocks is sitting so that it can fetch these blocks and then reassemble them to make the complete file. Data sanitization goes beyond deleting a file. It actually overrides data locations. So what it does is it overrides data locations with ones and zeros. Done in this way, recovery is not possible. Some good sanitization practice is the following. You always want to sanitize data before you dispose it off or before you reuse a drive. For hard drives, you want to use specialized disk wiping tools to erase the data that's on the drive. With cloud computing, everything now is virtualized. The customer does not have physical access to the hard disk to be able to delete or override this data themselves. So, how does the cloud service provider do this? They actually use what we call crypto shredding. With crypto shredding, we encrypt data from the start. After encrypting the data, the key that was used to encrypt the data is deleted to render this data unreadable, because as long as you don't have access to this key, you are not able to decrypt the data. It's there, but it's encrypted. You cannot use it. If you destroy all copies of the decryption key, then the data is safely shredded. Problems will crop up. Security when you use a third party organization for destruction. So, how do we guard against such problems that could crop up? Some best practice would involve going with vendors that have a good reputation. Another best practice will be to request a written proof of data destruction so that you can use this in future. If there's a case that comes up and someone was able to recover data that the third party did declare that they had destroyed, you can use this written proof against them in court and the liability shifted to the third party. You must not destroy data that is legally required. You must not also destroy data that is under a litigation hold. Common policies that companies work with. With the bring your own device policy, employees are allowed to use their own personal devices to access corporate resources. This means that an employee can use their private device to do work for the company and use their same private device to do their private business. A few considerations are important when bring your own device policy is in use. You might want to look at who may be allowed to bring in devices. Is it everybody in the company or just certain groups of people? You might also want to look at what kinds of devices are involved. Is it mobile devices only? Is it computer devices only? Is it both mobile and computing devices that are concerned? Lastly, you might want to look into the aspect of configuration. How will compliance be enforced when it comes to configuration? Will you oblige everyone that brings their own device to configure their Windows Defender, for example, so that certain websites are not reachable or not? These are issues that make debates in companies that are using bring your own devices. Also, things like software that you are allowed to install on this device. You need to control this because there are software that your company will not need for its operation, but because you are allowing people to use their own private devices, they might as well install this. And this software that they have installed may interfere with the work of the company. They may copy information about the company that they were not supposed to copy, and they may push this information out there. Here below are some few common challenges with bring your own devices. In terms of ownership, the challenge would be the device is owned by a user, but it contains corporate data as well as the personal data of the user. When it comes to support, information technology or IT department may be unclear on who to support this and how well to support personal devices. It's a personal device, but you might be tempted to support this because the person is using this personal device for the company. Privacy, the user may resist intrusive monitoring on their own device. Besides the bring your own device, you also have the choose your own device policy. In the choose your own device, the employees choose a device from the company's approved list of devices, and they have two approaches. The company can purchase and manage selected devices on behalf of the employees, or the second approach, the employee can use an allowance to buy a preferred device from a pre-approved selection. The choose your own device is a balance of personal preference and IT control. In the corporate owned, personally enabled, or COPE uh, mode of operation, the company must provide the device and allows the device to be used for personal things. The employee would install applications for use for work, but they would also be allowed to install personal applications for their personal use. Here, there is a stronger IT control involved because these have been given to the employee by the company, and so the company can properly ensure or lock down the applications that the user of this device will be allowed to use. But the user also has the flexibility to use one device for their private work and for the company.